Assalamualaikum. My name is Muhammad Farunwah bin Abdul Malik. My matrix number 211291014. Today I will present about Lab 5 effect of different PID value. Okay, for objective this experiment, first is able to use MATLAB command for PID analysis. Second is to analyze the effect to different value P, I, and D in a control system. Then this is a MATLAB command to generate transfer function of the system. We use GP equal to TF numerator and denominator, and to generate a system feedback into a system is system equal feedback GP and H. Then for the to add PID tunnel, C equal to PID KP KI KD. And to generate a system feedback with PID controller into a system PID equal feedback GPH. Okay, for the first, this is a procedure. First is 3.1.1, generate a system graph without PID controller and determine rise time, overshoot, settling time, and steady state error. For the first, I already make a coding and the result. Here is my coding. Okay, then I will run. This is my system, the system 1 over s square plus 3s plus 2. And this is my system, and the result is this. Okay, for the rest time is 2.59 second, and for the settling time 4.6 second, and peak amplitude is 0.499. Final value is 0.5. Okay, next is generate a system graph with and without PID controller. Set value of KP, KI, and KD based on given situation in table 3.1.2. And we move to 3.1.2. Yes. Okay, I already made this. Okay, then here is my coding. Okay, this is my result. Okay, when KP is increased, while KI and KD is constant. Okay, for when KP is increased, while KI and KD is constant, so characteristic peak response. Okay, this is my result. Okay, for Okay, for the overshoot for transfer function, when kp 15, ki and kd equals 10, the value is 1. I get this value 11.4, and one more. When kp 10, ki and kd equals 10, there is value is 1. I get 3.1. After that, this is the rise time. Okay, for the rise time for kp when kp 10, I get 0.4.9. Sorry, when kp 15, ki 1 and kd 1, I got the value rise time is 0.419. And when kp 10, ki and kd constant, I get 0.595. For the settling time, okay, for the settling time, when kp 10 is I get 13.4, and when kp 15 I get 15.2. Okay, for the final value is 1 when kp 10, and PID last value is 1. Okay, next. Okay, next is when ki is increased while kp and kd constant. This is my coding. For this is ki is key increase, which means PID1 is 3, ki1 is 3, ki2 is 7, kp is 15, that is constant. PID1 and PID2, for the kd1 with the value is 5, also constant. PID1 and PID2. Okay, this is my result. This is my value overshoot. I get 1.9. Then for the rise time I get 0.425, and one more is 0.457. For the stalling time I get 0.678, and PID1 I get 2.3, and lastly is the steady state. PID2 I got value 1, and PID2 also I got value is 1. So after that we proceed. For this is when KD is increased, while KP and KI is constant. So that mean KD is increased. That means for PID one system, KD1 is 3 and KD2 is 5. KP and KI is constant. That means KP1 15, also same with the PID2 system, that is 15, and KI1 and 2 also constant. The value is 7. Okay, this is my coding, then this is my result. For the rise time, I get 0.425. The PID one doesn't have a value. After that, settling time, the value I get is 1.65. For the PID2, I get 0.678. For the peak response, PID2, I get 1.02, and PID1 I get 0.2. Sorry, for the PID2 I get 1.9. And lastly, for the steady state, for value PID1 I get 1, and PID2 I get 1. For the task is also same. This my result without PID controller. This is my coding, and this is my result. When I got this result from the graph, I fill in the table this. This is with PID controller, KP 300, KI and KD, KP constant, KI and KD, KP and KD constant, KI, the value KI is different. This is my result. Okay, this is my coding and output. Okay, that is for me. Thank you.